Do it. All right, so I want to talk some more examples of Turing machines today. Actually, before we get into it, I received a correction by YouTube comment. Somebody watched the video from yesterday and said I got something wrong, and they are right. I got something wrong. So thank you, YouTube commenter, enjoying your free education. There is. So this is the standard example that we did last time of a Turing machine by marking off letters. And something about this is not quite right. So with my apologies, I would like to show you the correct version of this. There's a little mistake here. And unfortunately, we did 2 more examples that were basically slight modifications of this afterwards. And those also have the same problem, which you'll see it's easy to fix this problem. But here's the problem. Remember, just to refresh our memories, this is the Turing machine for a to the n, b to the n. And the strategy is you look at the first a, you mark it off, that is change it into an x. Then you go down and find the first b and mark that off, change it into an x. Then you go back to the beginning and you just repeat the process. So mark this a, then go to the end, mark this b. And then the fact that, I forgot to put the accepting state. This actually is where the problem arises in triggering the accepting state. How do you know when you're done? It happens when you go all the way down this string and it was all x's. If it was all x's, you will encounter a blank in this state. And that's your signal that you are done and the string should be accepted. All right? That, what I just said, is not quite wrong, but actually the problem with this is this accepts too much. For example, it also accepts something like AABB, AB. Check it out. It's because you would go through the same procedure as we did here, and it would end up Xing out all the, it would end up Xing out everything from the AABB. You'd be back in state 1 here, and you'd go all the way to the right. It would go through all of these X's. Now, it would not encounter blank and accept, but it would encounter just like a new block of A's and B's, and it would go through this whole thing again. And it would actually still work. It would still convert this A to an X, this B to an X, and then it would finally be accepted. And we don't want that, right? So truly the language that I was accepting here was actually any concatenation of strings that look like A to the n, B to the n, where you could have different values of n every time. So this machine is not quite right. It's because it is accepting too much, and the simple way to deal with that is to change our markings to be a little more intelligent. Rather than marking everything as an X, I'm going to mark the A as something and mark the B as something else so that you can actually remember this one used to be an A versus this one used to be a B. That's the problem here, is you have all of these X's, and there's no way to tell that actually some of them represented A's and some represented B's. So the strategy is, and I will tell you a little backstory actually. I will put a big old X through this. This is the correct idea, but not quite right. Slightly wrong. The correct idea is we should, there are a few ways to get around this, but the way that I'm about to say is the most applicable to other types of examples. We should mark A and B differently. You could mark the A's as X and the B's as Y. That would work. I find I'm going to mark A as A bar and B as B bar, just so that I don't have to remember which one they came from. So A bar is an A that's already been marked, and B bar is a B that's already been marked. All right? A little backstory. I had, I've been teaching this class for a few years, and in the past, I always did it this way. And for some reason, I looked at my notes from previous times, and I was like, man, that's so complicated. I should just mark them all the same. That's easier. And it's a little too easy. It is easier, but it's wrong. So sorry about that. I should not try so hard to simplify the examples, I suppose. So I'm going to mark, same strategy. Let's just see if we can do it right this time. You can still do it with basically the same states layout. And actually, when you do it this way with the more specific markings, it requires fewer things in the diagram. You can very slightly simplify it. Anyway, I started my starting state. We begin by marking A. So the arrow here used to say AXR, but now it's going to say A bar R. All right. So you mark off the first A. Now you move to the right until you encounter a B, and then you're going to mark it. Now, as you're moving to the right, what you're going to move past are other A's and perhaps some B bars that you've already seen in previous steps. So this I'm going to loop back onto itself. AAR, that is moved to the right past some other A's and also past some B bars. We're going to have to go past some B's which have already been marked. Okay. Eventually, after passing a bunch of A's and passing a bunch of B bars, we will arrive at a B, and that should be changed to a B bar. So this is going to say B bar, R. Actually, I'm going to make that an L. I mean, it's not too important, but you might as well. Because after you mark a B, your next step is to go back to the beginning of the string. So in that state at the bottom, I'm going to have a loop which moves to the left over and over. And here's one little bonus. Rather than going all the way to the beginning of a string, all the way back to a blank, in fact, you can just keep going until you see an A bar, because that would be a A that you've already dealt with, and then move yourself back to the right by one position. So I'm going to go left. I may have to travel through a bunch of B bars and also through some unmarked A's. This is moving back across the string to the left. Finally, when we arrive, unmarked A's. Finally, we will arrive at an A which was already marked, and that means we went back far enough. So I'm going to do A bar, R, right? If you moved back to the left and you see a marked A, that means that you have moved far enough to the left. In our previous example, we went all the way back until a blank, and then we had to move back past a bunch of X's, which is not necessary here because we're not going all the way back to the blank side of the string. You just have to go back to some A's that have been marked. All right? This is basically the whole thing. I'm going to have sort of an accepting state drawn in here. Anybody want to suggest what's your indication that the string is finally accepted? When you actually get to the end here, it looks something like A bar, B bar, B bar. And if I've gone through this loop here, maybe I'll just write out all the steps. If you start with A, B, B, then the first A gets marked, then the first B gets marked, then the next A gets marked, then the last B gets marked. And then after marking this B, the head will go back to the left in this state, past B bars, past this B bar, back to here. It's an A bar. It'll go back here, moving to the right, and I'll be pointing at this B bar. Anyone want to suggest how should we trigger the accepting state here? Yeah?
Would you do a loop of B bar and then have it, once it gets to a break, go to the accepting state?
Yeah. So once I think you meant from here? Yeah, from here, if you get back to this state and you're pointing at a B bar, that means you're done with all the A's. So here I'm going to say B bar, R, and then I'm just going to run through the whole list at the end to make sure there were no extra B bars. So this is what she said. Make a loop, B bar, R. And if we see a blank, this is slightly more complicated in the previous version of this example. If we see a blank, we do that. All right, so this business here is just checking to make sure that the whole rest of the string is only B bars and no B's left over. If your string had extra B's in it, you would need to do this last part just to make sure that there were no extra B's. All right, so this is my slight variation to that example that we did last time. And I don't want to go revisit those other examples, but can I just say similar changes for other two examples we did? We did a to the n, b to the 2n, and a to the 2n, b to the 3n. I believe those were the other two examples. You have to change the marking strategy in this exact same way. Doesn't require any new ideas, just do it exactly like this again. So, my apologies again for messing that up last time. Are there any questions about this? All right, great. I want to do some more examples today. Along the same theme, let's try A to then, B to then, C to then. This is very special language, or what's interesting about this language versus the other ones is this is not a context-free language, right? So this one has no context-free grammar, so in that sense, this is actually a much more complicated language than just A to then, B to then. But the Turing machine strategy is actually basically the same. You go through, you mark the A's, you mark a B. Every time you mark a A, then you mark a B, then you mark a C, and then you go back to the beginning and you do it again. Really, the same thing that we just did in that example we just did. It works in this case also. So we do this by marking. Let's see if we can make it happen. It is, slightly different, but it's a straightforward kind of difference. So I'm going to start in the starting state. And we begin by marking an A at the very beginning. So I'm going to go, it turns out, just because I've worked this out already, it turns out that this diagram will require just 4 states like this, just so you can format your paper correctly. And then some extra business for the accepting state. But this is the general shape of the Turing machine. We're looking for A to then, B to then, C to then. So starting from the starting state, we read A and mark it, and then move to the right, and then go into the next state here. A bar to the right. All right, and now I want to move to the right repeatedly until we get to a B, and then mark the B. So I'm going to put some loopers here. Anyone want to say what should be on that loop there? You got to think, what are the letters that I'm trying to move past at this point? Yeah.
A/A, and then to the right.
Yeah, A-A-R. You have to move past other A's. Or, and I think there's another thing you might have to move through.
B bars.
Yeah, B bars. Remember, like some kind of intermediate step of this would look something like this. Right? So in this, what we're doing right now is this moving through this area, and you might have to go past some B bars to make it to where you want to be. B bar, R. All right. There should be no C's in this region or C bars. If there were, you should stop and reject. The machine would jam. Okay. After B bar, I expect to see a B and mark it. So this arrow will go to the next state, and it says B bar R. Right. That is marking the next B. All right, what should we do from this state? Any suggestions? BBR, yeah. This is a looping edge, right. In this state, we want to continue moving to the right. Now in the string, we're sort of in this region, moving past these other B's and also past the C bar. So she said BBR, and you also need C bar R. Okay. What next? There's going to be an arrow that goes down here. What should be on there? On there?
C bar.
C bar. Would you mind if I said L?
Yeah.
Actually, it doesn't matter, but you might as well say L here, because the next thing you're going to do is to move yourself to the left. Great. Okay. What else? Down here, what I want to do in this state is move back to the left. So I'm going to put another loopy thing here. What do you think? Fill in the blanks. What do you say?
C bar, C bar, B, B, B bar, B bar.
Yes. So these are all with L's, right? Yeah, actually there's many things we're going to move past. He said C bar, BBL. Did you say B bar? Why not? B bar, L. Anything else? Yeah, we got to go through A's also. A is kind of, what we're looking for is the leftmost A, but we have to go through the other A's in order to get there. So A, L. And then finally, we should stop, at least this part, we should stop when we see an A bar and then move once more to the right and move back to the beginning state. So this is A bar, R. And that's one whole loop through this procedure. I like it. Any thoughts about that? Questions about that? This is the basic structure, although we do need to add some stuff on concerning the acceptance at the end. So when we're in this state, what exactly is it that we're going to see that means we are done marking things off? You got to think about. Yeah, I think you see B bar. If you're on the last time through, your string looks something like this. Everything is barred, and you just went through this thing, moved past all these guys, B bars, but then I saw a bar and moved to the right once more. If you're really done, you'll be pointed at a B bar at this point. So that's going to be my sort of trigger to go out to the accepting state. B bar, R. Would you say at this point I can just immediately accept, or sometimes we have to run all the way through the string to make sure there was no leftovers? What do you think? Accept immediately? No. Run through and make sure there's no leftovers. Yeah, you have to make sure that there wasn't any extra B's or any extra C's, because if there were, you wouldn't have noticed it. You wouldn't have noticed it already. So far, we've just matched off one A with one B and one C each time, but there might be extra B's or extra C's. So what we have to do at the end is just ride all the way to the right through everything, and they better all be B bars until they're not anymore, and then they better all be C bars. So I have one state to run through all the B bars, and then I'll do C bar, R. This state runs through all the C bars.
Can we do it together?
This is a good idea. Yeah, I think so. Yeah, I was going to say, well, they're not allowed to be mixed together. They have to be all the B bars first and all the C bars first. But
Really check that.
We
No.
only check like they are in the sequence, right?
I think, for example, no, it doesn't matter. Yeah, I'll put them all together. Because if they were not in order, you would have noticed it already. Yeah. Okay, then we go to an accepting state if we actually make it all the way to the end and see blank. So this is blank, blank. Great. That's equivalent to what I wrote before, was also correct. It's just, this is better. I mean, fewer states. Yeah.
What if n equals 0?
What if n equals 0? This is a good thing to think about.
We just do blank R straight to the from start to finish.
Yeah. This doesn't work if n is 0. Thank you for that. So, yeah, just do this. I think this will work. I'm a little, it is right to be concerned about what if I went through a couple times and then did this? Would that accept some other weird thing that I don't want to accept? But I think it's not possible to go through this and then see a blank in this state. I think the only way you could ever see a blank in that state is if you started with the empty string. Yeah.
Can there ever be blanks between an input and an array?
No, because the input string is just a string of, in this case, A's and B's. It's not allowed to have blanks in it. Yeah. Thank you for that. This is a good point. And now that you mention it, this may be necessary in the other examples too. You mind if I scrolled up? Yeah, you need that in this case too, because if you start with the empty string, it will jam immediately and be rejected here. Thank you for that. Leave a comment. So put one of those in there too. Thanks. I believe even the version that I wrote last time would not work properly. No, it would, because this ended up being here anyway. I got lucky because this was already attached in the correct way. But yeah, thank you for that. Excellent. Everybody gets it, right? I got 2 more examples. We got plenty of time for that. 2 more examples. One is just another similar kind of marking procedure, but you'll see it has an interesting other kind of structure to it, the Turing machine. Let's try a to the n, b to the m, c to the n plus m. So it has some amount of a's, followed by some other amount of b's, followed by an amount of c's, which is the amount of a's plus the amount of b's. All right. In this case, the number of a's and b's are unrelated to one another. It's just each of them is related to how many c's there are. So I'm going to mark this again. I'm going to do it by marking. In the previous examples, it was always like I match an A with a B and also with a C. But you don't want to do that in this case because the number of A's should not be related to the number of B's. Anyone want to suggest another kind of general strategy?
Would you mark that A's and B's is the same thing, so then that matches the number of C's?
This is not my strategy. If you mark, you mean before doing anything, you just like change all the B's to A's?
Oh, I wasn't thinking that. I was saying like you could mark all the A's and B's as like X's and all the C's as like C bars.
So like each time through, I change a A to a X, a B to a X, and a C to a C bar?
A C to a C bar. Well, I was thinking you could kind of do it like back and forth like you had done with the A to the N, B to the N, but I'm not sure if that works.
Yeah, one thing, I think you were not suggesting this, but one thing that will not work is you don't want to like mark a A and then mark a B and then mark a C, because the A, that's like too many markings at once. It's more like each A goes with a C and separately each B goes with a C, right? Yeah, is that what you?
You could make all of these A's, or you could like go from A to C, and then after all the A's, another would B to C.
Yeah, this is my strategy. Make one sort of similar to before, one of those sort of triangular loops which matches or marks an A and then marks a C, and then go back, does an A and then a C. And then once you're done with all that, you do another thing which marks a B and with a C, all right? Yeah, another strategy which would work is before doing anything, you could just go through and change all the A's to B's or something, and then run through the whole thing again and basically copy our previous machine for A again, B again. But I don't want to do that. So what we're going to do is mark A and mark a C, and then repeat this until all the A's are done. And then do it with B's and C's. Right? That's my general idea. And each of these, this is really sort of two separate loops. That's what makes this example more interesting compared with the other ones. All the other examples we've done have been just kind of one loop with a little accepting state thing at the end. This is really going to be kind of two loops. So the structure of how this works is going to be something like, I have my accepting state, which goes through a little triangular loopy thing, and then it goes to another one of these, right? That's the basic way that this is going to look. And then some extra business for how to tell when it's accepted. This is the overall architecture of the machine. Let's see if we can do it. So I'm going to make the first little loop here. Let's go around clockwise. I'm going to begin by marking A bar R. And then in this state there, we are going to move to the right until we find a C. You have to think about what exactly are we moving to the right past as we're moving. It could go through other A's, AAR. It could go through B's. And I believe it could go through C bars. We might see some C's that were already marked. So C bar, R. All right. I don't think you can see a B bar at this point because we're going to mark all the A's first before we start marking any B's. So you're not going to see any B bars at this point. Okay, then after doing that loop for a while, we will arrive at a C, which gets marked. So this is going to be C bar, and I guess L because now we're going to go back to the beginning. Back to the beginning means move to the left past let's see, we might go past other C bars, we might go past B's, and we might go past unmarked A's. So we go out to the right, mark the C, come back to the left until we get to a marked A. And then I'm going to do A bar, R. So this is our first little loop there. By the time you do that over and over again, you will be marking off all of the A's, and each A marks off a C, all right? From this little triangular diagram, when you're done with all of the A's, your signal will be at this point, your head will be pointed at a B, right? That's because you've exhausted all of the unmarked A's. The next character at this point will be a B. So what you want to do if you see a B at this point is mark it and then move yourself into the next loop. So my next loop is going to be another one of these things. Sorry, this is kind of in the way. And here I'm going to, it's going to look like this again. Somewhat strange thing is this arrow is going to say B bar R. I begin with an unmarked B, and I'm going to mark it. And then this arrow actually, it goes to that state. It doesn't go maybe where you expected it to go. It's because that state is the one that you get to after marking your first B. And we are getting there by marking our first B. So actually it has to jump into this point of this second loop. Slightly strange, but not a big deal. Anyway, from here, we do the same old thing. So I've just marked a B. I need to move to the right past some unmarked B's and past some C bars. Then I encounter a real C, which I mark. And then I move back to the left through C bars and B's until I get to a B bar, like so. And then this first arrow is a B bar R. That will mark the next unmarked B. This is really it's the same type of little loop that we've been doing all along. All right, and then how do we decide we're done? We will finish marking all of the B bars if we go through this loop a bunch of times and we end up in this state pointed at a C bar, right? That means that we've actually worked through all the B's, and that's going to go out here to our accepting state. So C bar, C bar. And as usual for these types of problems, we may have extra C bars left over at the end. So we need one little guy like this, C bar R, and then blank, blank, blank R to our final accepting state. This is to make sure that there are no extra C's at the end hanging out. All right. And again, to satisfy the gentleman in black, there should be an arrow for the empty string. If you happen to start with the empty string, it needs to be accepted. All right, kind of complicated looking, I guess, although it's really the same ideas as all the other examples. They're just packaged together in a slightly more sophisticated way, maybe. Any thoughts about that or questions? You'll have some practice with these on the next homework assignment. Turing machines by marking. All right, I got just one more example. We might finish a little bit early if that's okay with you. This is another example which has to do with marking, but there's something a little different or more interesting about this one. I would like, let's go, how about a Turing machine for this language? X in AB star, where X equals X reversed. This is palindrome type strings. Like, for example, A, B, B, A, B, B, A. This is a string for which X equals X reverse. All right. Again, my strategy will involve marking the letters. Anyone want to say in some kind of general words, what should the marking strategy be this time around? They're all in a mixed up order, so it's kind of different from the previous examples. But.
You go from the start and then you go into the end.
Right. So I'm going to start by marking the first letter. And then you run all the way to the end, and you mark the last letter. And it better be the same as the first letter, right? And then you go all the way back to the left. I suppose the leftmost unmarked letter, which would be that next B, and you mark that, right? And then you go all the way to the rightmost unmarked letter, and you mark that. So it would say B, A, B, B, bar, A, bar, like that, etc. All right? What's interesting about this is, if I were to write this out in words, I would say mark the first letter, and then move right all the way. I suppose all the way to a blank and then back up one, I guess. That's how you know you made it to the end. And then you mark that last letter, but only if it was the same as the first letter, right? If you marked an A at the beginning and that last letter is also A, then you should mark it. If that last letter turns out to be a B, you should just stop and reject. So move all to the right all the way, and then if it matches, mark it, right? This is the interesting part about this one as opposed to the previous examples. We've actually never done something like that. How do you, what it requires, because this business in the diagram happens at a different state from this business. So you have to somehow draw your diagram so that it can remember what the first letter was. You have to remember that the first letter is A by the time you get down to this state in order to tell what to do at the end there. How do you remember what the first letter was? And the strategy here, we're going to use marking. Anybody have an idea? Yeah?
You branch it off, so one side goes to A, one side goes to
Yeah. The strategy here is going to be branching parallel paths. together with our ordinary sort of marking back and forth strategy. Excellent idea. Branching parallel paths. The idea is you mark off the first letter, and if that was an A, you go sort of on branch A, and you do the whole usual thing. You move to the right and then mark it off and move back. Whereas if the first letter was a B, you do that same stuff, but you do it along a different branch so that you can behave slightly differently at the end. That's the idea. So the structure of this one is basically going to look like my starting state, and then this is sort of path 1, and then this is like path 2. And they eventually come back together at the end, because after you do sort of one pair of this marking, then you can forget about what it was before. And then that whole thing loops, which you could make a big arrow going back to the beginning like that, although it's going to look cuter. I'm going to draw the arrow going back to the beginning through the middle. But anyway, the two branching paths, they will have basically all the same arrows on them with one slight difference. But that's how you handle this kind of a situation. Let's see if we can do it. So I'm going to start off with my starting state. When you begin, you immediately see either an A or a B, and this will immediately cause you to go into these two branches. So if you see an A, let's go up on the top branch. I will mark it, of course. And if I see a B, I go across the bottom branch, mark the B and R. All right? Now, in either branch, actually, for this next step, both branches will look exactly the same. You just move all the way to the right until you get to a blank, or until you get to an already marked letter if you're starting sort of in the middle here. So I'm going to move all the way to the right. It should go through A's, also through B's. But if you see a marked letter, if it's either an A bar or a B bar, or if you see a blank, that means you went too far and you should back up one spot to the left. So this is going to say A bar L, B bar L, or blank L. All right. We continue to move to the right until we bump into a marked letter or a blank if you made it all the way to the end. And then you've got to back up one spot to get back to the one you're looking at. And I'm going to write exactly those same steps down here, because the other branch, if you had read a B to begin with, you do exactly the same stuff. So this is BBR, AAR, and then this is the same labels here. Blank L, A bar L, and B bar L. All right. Okay, what should we do next? Let's say on the top branch. So this is the branch in which the first letter was an A. Then you move all the way to the end, back it up one spot so that you're now pointing at the rightmost unmarked letter. That one better be an A, and if it is, you mark it. So this one, I'm going to say, at this point, actually, the two branches can come back together. Oops. A bar, L. And this one says B bar L. And now the clans are united again. All right. At this point, that first A has now been marked off with a corresponding A, or that first B has now been marked off with a corresponding B, and we've completed the matching. The only thing left is to go back to the beginning. So in this state, I'm going to make a loop moving to the left every time. And you want to back it up to the left until you see a marked letter at the beginning, right? Then that means you made it back to the beginning. So here, I'm going to go AAL, BBL. And if you do see a marked letter, that means you made it all the way back to the beginning, and so you should go back to the original first state. Like so, this would be A bar R. Because when you keep moving to the left, you're going to overshoot the beginning of the string. So you want to back it up to the right one spot. B bar R. We don't know if the thing we end up at is a bar or a B bar. All right, excellent. We just need to decide about the accepting business here. It's going to happen here. This is a common thing in the examples that we do. The trigger for being accepted will happen here. If you go all the way through, when you're actually done, it will look something like AA, B, A, B, AA, and like all of these guys will have been matched. Something I didn't mention before is there may actually be a lonely letter in the middle which doesn't match anything, and we'll have to think about, is that really a problem or not? It could look like that, or maybe there's not an extra letter in the middle. Maybe it just looks like this, right? I think actually the second case is a little easier to think about. What would happen in the second case? Over here, you would have marked off the last letter that gets marked off is actually this one here, right? Sort of in the middle, but on the right. And then this looping thing here actually would not go anywhere. You would just do this. It would move to the right. Oh, sorry. It would have marked to the left and then move to the left. So actually it would point here. But anyway, this loop wouldn't do anything. It would move to the right and it would say B bar. Whereas ordinarily when you move to the right here, it would be pointing at the next letter which is unmarked. But if you move to the right and it is marked, that means actually you're done. You must have marked off everything. Do we need to worry about extra stuff hanging around on the end? This is something that was an issue in our other machines. There were like extra C's. You have to run through the rest of the string. I think that's not possible in this machine because the way this machine works, it actually does go, we already went to the end to match these things up. So we don't actually need to check the end. I think it's like this: A bar, B bar, B bar, R, and accepting. If you're in the first state and it's pointing at a marked thing, it means you've actually made it all the way down to the middle. All right. Now this is not quite done. That was this situation when there was no extra lonely letter in the middle. What if there is an extra Malcolm in the middle, monkey in the middle, as they say? How many other ways can I say it? I don't know. What if there is a monkey in the middle? What would have happened then? When we come back here, this monkey in the middle actually, if you continue, it would continue and mark that one. Then it would move to the right through unmarks, which there are none. It would be looking at another mark, so it would go over here. I believe in this state, if you are looking at a marked letter, it must have been the monkey in the middle. And in fact, in this branch, it must have been an A in the middle. This should also accept if you see A bar at this point. Oops. I drew that in the wrong spot. If you see A bar here, I believe the only way that can happen is if there was a monkey in the middle. You see an A bar right there, and then it should be accepted. And similarly on the bottom, if there was a B monkey in the middle, it looks like this. Those are how you have to make the accepting states. I hope that that's right. I hope that you're getting the idea at this point. It can be a little tricky to figure out. I hope that everybody understands the basic idea of this, but being exactly sure that you're not going to accept any wrong strings and that you are going to accept all the correct strings is not at all easy here. I hope I did that right.
In the first state, you also need blank, because this would accept epsilon.
Yeah. Yes, she's right. I'll put that here. Yes, thank you for that. I think I have a hard time remembering the empty string. Yeah, thank you for that. All right, I think that'll do it for today. We'll do some more examples next time.